Hey everyone, hope you all having a good morning here, and it's always good to be back here at this stage, and well, twice in a row, so that feels extra special. This time I even brought a friend alongside me, and today we're going to be talking about building versus buying, and how around three engineers decided it would be a very good idea into creating an in-house SCA tool. So before we get to business, this is who I am. My name is Diogo Lemos. I'm a security engineer. I've been working with security for over 6 years, and I joined Checkmarx, then moved on into Flutter Entertainment, where I developed most of this project alongside this friend here, and now I'm at the OLX group. No.
Hey everyone, I'm Fábio. I'm a security engineer at Flutter Entertainment, known in Portugal mainly as Blip. We are in Porto. I started the company back in 2016 and I worked there since. And today I'll be with Diogo presenting this nice challenge. Diogo will go through the agenda right now.
So we'll start introducing what is SCA, then we're going to be talking about tackling the issue itself, then the solution and the tools you use, moving on to the solution walkthrough and the demo, and then some key takeaways and future vision. So, introduction to SCA, and it's exactly understanding what's the importance of dependency management in modern software development. And SCA stands for Software Composition Analysis, and it's a process that involves identifying and analyzing the open source and third-party components in a software code base. So, why is SCA important in modern software development? Because nowadays, applications often rely on multiple open source libraries, and these libraries are not just for convenience tools, but also essential parts itself of the code base, and each of them creates potential risks. And well, now imagine vibe coding, where developers just install dependencies freely, unaware of what each other brings beneath the surface. And why has this become a critical problem? Because what once seemed like a very simple task, installing a few dependencies, has evolved into a complex and web indirect risks that can compromise software security and stability. And well, we have transitive dependencies, which are those dependencies that when you install a certain library, that certain library depends on other libraries, and developers may not know the full chain of dependencies that comes when installing a single one. And that leads to vulnerability detection issues, because if a vulnerability is found in one of those deep transitive dependencies, developers may even struggle to understand where the issue is and even if it is a real issue. And when scaling the issue in large-scale organizations and organizations with multiple applications, manual tracking and auditing dependencies is ineffective. You kind of need like an automated process that will go through all the process at the same time and look for security vulnerabilities that can go unannounced. And well, we come up to the real issue, which is dependency management in modern development, because developers often use package managers like NPM or even pip to install dependencies, and they are not aware what comes with all those libraries. They just go there and do like NPM install. And this includes both those direct, that you will install just NPM install and you will install a dependency and everything will be okay, but it also includes those transitive dependencies that will depend on other dependencies, and by installing a single dependency will bring alongside other dependencies. And well, this brings us a little bit of dependency hell, because having all these layers can create complexity, and developers may even not know that they are installing dependencies that depend on other dependencies, that even those are vulnerable, not exactly the dependency that they installed, but the other dependencies. And well, traditional tools like NPM audit and pip freeze are good, and they go there and you just use it and they list all the dependencies that are used in the process and the project. But they are quite inefficient when you go applying this to a large-scale organization where you will have different environments, different clusters, and doing this all, you will need a proper solution that will manage everything in an automated way. So, what we really need to build an efficient solution that will answer all our points. So first, we'll need to build an inventory of dependencies, And also we need to track those versions because we need to know which versions we have for which dependencies. And well, this also brings to automated vulnerability detection because we need to be proactively checking those dependencies and checking if those dependencies come with vulnerabilities. And we need to provide fixes and remediation because if we have a list of all the dependencies and a list of all the vulnerabilities, but we don't take action, the list just sits there. And most of the dependencies, some of them might not even have a fix for it yet, so we need to find some kind of solution, an alternative package or something like that. And this is why thinking and continuous monitoring is important because you need to be continuously improving, checking if those vulnerabilities have been solved, and if they have been solved, you need to be checking for others that may come up. And most important, I would say, we need a place to manage and display those dependencies and those vulnerabilities because you can have a list of inventory of all applications, all the vulnerabilities, but if you don't have a single place where developers may go there and understand what is vulnerable and what's not vulnerable and how can they apply a fix and which versions have a fix for it and which version should they patch it to, this will be for nothing, and that will ensure in the end license compliance and reduce the overall operational risks. So, tackling the SCA issue, and we'll talk a little bit about the steps that we need to address and the real need for a real solution and a scalable one. So, to manage vulnerabilities, I would say we need to start creating a list of inventory of components, a list of all the dependencies that we want. And since we are a large-scale organization, we also would need some kind of solution that would support multiple code bases. And the funny thing, every time in the past that we have an instance, let's say we have this vulnerable dependency and create a big incident around it, we would use a good tool called SourceGraph to search around all the repos where that tool is used. But having that static list isn't enough. We need data to be synchronized in real time so we can keep quickly a good track of the dependencies and their versions and ensure that all developers have visibility and can take action when the problem occurs. So we'll be able to answer to questions where this dependency is and which versions it has. And does it have a fix for it yet? And well, we come up to that. So after having that initial inventory of all the dependencies that we have on our organization, we needed some kind of robust solution that would cover all that I talked about. And we went on the market searching for all the solutions out there, but all of them had some real challenges that we weren't liking them very much. Some were expensive, others only support one code base, and others had poor user interface. So we kind of need a tool that would answer all those things, but also have some kind of customizability. So this leads to ourselves to a conclusion that we would need for a tailored and cost-effective solution that we could integrate across our organization and meet all our specific needs. And well, we also took this as an opportunity to build new stuff because I think it's always good to go there to learn about what is an SCA and if we could implement one. And well, that's what we come up here because during our investigation of all the solutions we look around, we identified 4 key components. And one of those, being the first one, is creating an SBOM, which stands for Software Bill of Materials, and is basically a nested list, a nested inventory that lists all the components, libraries, and all the dependencies in a software application. And that we also need to, now that we have that list, we need to have something to compare that list and check if they have vulnerabilities. So we need to have a dependency database, which includes both vulnerabilities and end-of-life versions. And well, now that we have a list of all the dependencies, and now that we have a dependency database and end-of-life versions, we need to have some kind of place to show the data that we'll be able to join between those things. And it's a platform to both display and manage dependencies and also vulnerabilities. And well, this is the solution we're going to present now.
So I'll give you a walkthrough of the solution that we did. And I will start with the tool that we chose to build this application. So in order to generate the software bill of materials, we chose Cyclone DX from OWASP. It's a really nice tool. It's one of the standards that we have right now, and it generates the SBOMs for the applications. to query and to get all the vulnerabilities information, where we are only relying on OSVDev from Google right now. They have a really nice open source database that you can query, and you can send software bill of materials directly to them, and they will output your software bill of materials with the vulnerability themselves, which will help a lot on your debugging, your processing. And to check end-of-life dependencies, we are using end-of-life.date, another tool that you can just go there and use. We are syncing the data into our main tool, and then for data processing and displaying, we are using a tool that we developed. It is called Surface Security. This tool started in 2017 on the former AppSec team of our Paddy Power Fair, right now Flutter Entertainment group. This is a Django framework that has a lot of integrations, and it is really scalable the way that we built it, because you can integrate more apps in it. The tool is open source, and you can have a look into it on GitHub. We'll just share the repo right there. So on the challenges themselves, identifying and processing dependency, this is a really tricky one, because, okay, we know to identify the dependencies, all we need is to generate the software bill of materials, but then you work in an organization with 40,000 repos, and then how can I generate all the dependencies for all of these repos, and how can I make people adopt this process and to adopt this on their daily basis? So this is one of the biggest challenges that we have while developing the tool. We need to create some templates and for them to use, of course, and to generate the dependencies and sort of an automated way to have the process working for them. So synchronizing the SBOMs. We needed a process also to get all the bill of materials that were generated, that are a lot, of course. After we start onboarding tools into the SCA, we'll have a lot of software bill of materials that we need to sync, and then we need to manage the vulnerabilities. And of course, as Diogo mentioned, create the custom dashboards for the teams to go there, use, and for them to be a little bit proactive, because it's impossible from a security point of view to manage all of this in the security team. So you need to pass responsibility to the development teams to use the tool and to make sure that we are in a better shape from a security point of view. So our tool is consisted in two main models. We have the Surface SCA, that is the main model, is the SCA tool, and then the SBOM repo. The SBOM repo is a simple Django tool that consists in 2 DB models, where we store only the SBOM data and all the vulnerabilities from OSVDev. We consume the API, you get the vulnerabilities, it gives you like 500,000 vulnerabilities so you can use on your tool, and we are processing the SBOMs to store this. And after that, we have Surface Security. I'm not sure you can understand the models because they look a little bit small, but I can explain them to you. So, on our SCA, we have multiple models, the main one being the SCA dependency. The dependency model will be the parent model or everything. So this parent model has a many-to-many field for itself, so we can have a dependency tree built based on this. We have the end-of-life dependencies model also that we sync separately, but then we have multiple relations in the database that we are able to go from a dependency to an owner. And this is what we wanted to achieve building this tool, because nowadays, in big companies, having a tool is great, having the results is awesome, but then who is the owner of this vulnerability? Is an answer that is really hard to answer nowadays in big companies, because ownership is one of the things that is harder to achieve properly in a company nowadays. So our process consisted in creating the bill of materials, we scanned it with OSVDev, we search if this dependency is end of life, crossing the data with end of life.date, we push the results to Surface, and then we have our views so people can use them. So the way we implemented this, for this to be scalable and usable in our reality back in time, and it's working as is nowadays. We use Jenkins to generate all our bill of materials and GitHub Actions. Then we send the results to Surface. We only have Surface here because right now Surface and the SBOM repo are working together. Because SBOM repo is just a Django app, so we can install it inside our application surface itself, and we have everything in the same place. Of course, we query the OSVDev to get the vulnerabilities, we push the data into surface, and then we have the UI right there, the reports, and score. It's right there to mention, but it's just a way that we created a process inside the organization to gamify a little bit the security process. So this is just a side note for what it is with the score. The key features of our tool are already mentioned: SPOM synchronization, dependency processing. We group the dependency by projects, of course, otherwise it will be a mess, and I can show you after our first version that it would be a mess to manage without having this grouping and vulnerability management, so a way for people to manage their vulnerabilities. Extra tools, we have, of course, besides the views, we have a check to see if the dependencies are in public registries. So we have a lot of internal dependencies, and having the possibility of those dependencies not pinned and be available in a public repo can lead to dependency confusion if the version is not pinned itself. So we are checking if our internal dependencies and all the dependencies are available in the public registries. So we try to help in mitigating the dependency confusion. We are integrated with CI/CD. We have our own suppress mechanism, and of course we have the automatic updates. And of course, we identify if a vulnerability is fixable or not, because there are vulns out there that there are no patches yet, so not everything is fixable from a developer point of view, for a development point of view, so you cannot just go there and upgrade the dependency. And in these situations, it's good to know that you need to take other kind of actions besides updating it. So after this, I'll give you a small walkthrough on the tool that we have, and I will show you what we have right here. Let me check if I have this here. Let's just organize these screens. Okay, it can be like this. So as a start, I already have. Is this okay to see right now? Yeah, okay. As a start, I have two software bill of materials that I generated previously for the presentation, because sometimes it takes a little bit of time to build. Both of them were generated with CycloneDX. It's a surface SBOM JSON and the node code, just as an example. So, sorry. Ooh. So this is the kind of information that you can have on a SBOM. As you can see, the surface one is really small, and we have a lot of information in a single place for this to be usable by someone, just to take an SBOM and to get information from it. Of course, you can get the dependencies in the dependency list, but this is not usable to start. So right here I have my Django server. That is our tool surface that is running. I'm opening Slack by mistake, sorry. Oh, hi. Our Django server, and right here, this is surface. So I started with a clean database. The only thing that we have right here are the vulnerabilities from OSVDev that takes like 20, 30 minutes to sync right now. So it was not a good idea to have them here. And we have the information from end-of-life.date that I can zoom in a little bit, maybe it helps. And this is the only things that we have for now. As you can see, there are no dependencies, no projects, the database is completely clean. And this is the repo that we will be scanning. It's surface security, is basically a fork of the repo that is open source, and this is the repo that we'll be scanning for the SCA. So the way that we start, we generate the SBOM, and then we ingest the data into the surface. So we'll take our curls, that I hope they work, and we just send the first bill of materials to the SBOM repo, and then the second bill of materials to the SBOM repo. Two pull requests, two bill of materials were created. If I go to show you the SBOMs, now we have two SBOMs on our SBOM database. This is just API-based. There is no views for this. It's just the database where you are storing the SBOMs. If I take this and open you this one, it should open you. Let me take this one, and it's not this one, but I can just copy this and paste it for sure. I'm sorry, no, it's just a space. I give it a space right there. So this is the bill of materials itself that we just pushed to our tool. We have the list of the dependencies, and you can go through. You can say, this is a Django package, this is Surface itself. And for now, we only have the dependency tree and the bill of materials. If I give it the parameter vuln data, now it's going to svdev, sending the bill of materials and getting the results with all the vulnerabilities that were identified for this bill of materials. It looks the same, but here on the SBOM repo, we have a vulnerability list for this package itself. So for Surface, in this case, Django 5.2.4, it was the version that was on the repo back in time when I scanned it, and we have all the information right here. And right now, if I zoom out, we still don't have anything on our projects, because that is the second step. This is the repo where we are storing the bill of materials and the vulnerabilities. And if I run the sync SBOM repo, that will go through the SBOMs and get all the information that we have in there, all the bill of materials and the stuff that we have in there. We'll start getting this information into Surface Security, into the main tool. It gives a few warnings on the versions, because we are using semantic version to check the versions if they are valid or not, and there are some that comes from the API that are not really valid versions. So if this worked, right now we have two SCA projects right here. But let me go just a little bit back for our version one. Our first version was this. This was the first version of the bill of materials that we just started with the dependencies view. And we have all the dependencies right here. Of course, we can go and search by Django. Let's go 5.2.4. Not like this, but 2.4. It should appear right here. And if I search for it, we have a dependency. We have a tool that we have some recursive methods to build our dependency tree of it. And we also have the parent tree to see which dependencies are using this version of Django. This was just the first version, completely, I wouldn't say useless, because it's more than having anything, but it's not really ready for someone to use. So we had then the version 2 where we built the SCA project view. This is basically the same model. It's SCA dependency organized in a different way. And based on this, we are able to get the information of the vulnerability that we have, which is a repo, and we can download the SBOM if someone wants to have a look into it, right? So on the dependencies, we can have a list of the dependencies of a project with some filters right there. The vulnerable one is interesting because you can see all their vulnerable dependencies of a project. If you look into there is the Django 5.2.4, the one, I got really happy when I saw the Django 5.2.4. This is the critical one in there is a few days old, actually, and when it appeared, I was really happy, so, because, oh, the tool works. This is really recent, and the tool got it, so nice. This is working, and it was a really nice moment. And then you have the vulnerabilities view. On the vulnerabilities view, you can see all the vulnerabilities, information that we get from osv.dev. We have a small description just for people to know what it means and what the vulnerability is. And of course, we have a suppress mechanism. Let me just go back to the projects to show you that we have 1 critical, 7 high, and 5 medium right here. And on the suppress mechanism, let's try to suppress just a normal high. 1 can be the first one. Of course, we need to have a mandatory suppress reason. Otherwise, developers will go here, press the button, and move forward because they want to deliver, and deliver is the most important thing of a development team. So let me put something on the description for you to know. And right now, it should have updated the counters. As you can see, we have 1 critical, 6 high, and 5 medium because the other one was suppressed for a reason. And someone put his name right there to say this is suppressed because of this reason, but if there are any problems related to it, we have ownership of that action, and this is really important. Other than this, we wanted to have the possibility of making this user-friendly for developers. So, okay, developers now, they know that we have these vulnerabilities in our dependencies, so the best way is to update. And then, should I update to which version? I don't know. To the latest, it might break, to the major one, minimal. So we had an integration right here that calls renovate. And if I have Docker running, that I think I do, and if I press this button, it should call renovate itself for Django. And it will, in the repo, create a merge request updating the dependency for the dev teams to go there and just review, test, of course, and merge in the end. Let me check if it's working. It said it did. Let me refresh it. There it is. We have a pull request for the teams. And now this pull request is upgrading Django to the latest fixed version of this critical CVE that is 5.2.8. And all you need is to check if your code is running and merge it. So on the SCA part and on the tool itself, this is it. And now I'll go pass the baton to Diogo to give you the key takeaways and a full overview.
Yeah, let's recap all of this and give you some key insights into what's important and our plan to expand the tool and enhance the solution itself. So, some key takeaways. The Django SVM repo is a pip package. You can just do pip install and you install the Django SVM repo into your application. And once you install the SCA bit, you will be able to resync multiple vulnerabilities and end-of-life versions. And, well, it might be biased, but I think the tool is easy enough to go to GitHub to understand and to implement and set up to your own needs. And it's also an opportunity to get into the surface security world because we have a lot of apps on there. Other than the main app and the SVM repo, we have others that are quite useful. But, well, you just go there and take a look for yourself. And well, it's an open source project and it's a solution that is out there for everyone, and we call other contributors because we put a solution out there, but it's always good to get some feedback into it. And I want to highlight the importance of solutions like this because most of us use open source tools in our own development, and we use a lot, like you can see, to implement this solution, and it's our opportunity to give also something back to the community that it's open source and it's out there for everyone. And what we plan on doing in the future is improving a little bit on the documentation. I think the tool itself and the whole Django ecosystems, the Django Surface ecosystem needs a little bit more documentation and some kind of governance to improve on a public roadmap, say like future release. Otherwise, the people just go there when they want to know the tool, but will not go there for future updates or anything like that. We need to reduce a little bit the tech debt because there are standards and everything that we need to follow across the whole application, and doing external communications because we can have a great product. And I really think that this SCA is a product that is useful and it's out there, it's open source, so just go there and use it. But we need to do security meetups like this one and to talk with the guys and say, okay, we have this tool, because even if we have a great tool and nobody knows about it, nobody will lose that tool. And well, I think that's all, folks. Do you have any questions? We are here to answer, but feel free to go take a deep look at the GitHub to understand what we have down there on the SCA app, when we have on the whole Surface Security app. And that's our LinkedIn's and that's our emails, and you can ask anything. Thank you.
Hi guys, thank you for the presentation. I have a quick question. On the process whether you recommend an upgrade path to those vulnerable libraries, are you just taking into account like the latest available version and confirming that it doesn't have those specific vulnerabilities? Or if, for example, you also take into account things like determining if, for example, there is breaking changes when you're going to upgrade to that library because that can have an impact on the upgrade itself of the software and developers need to refactor code.
Of course. So right now we are relying 100% on Renovate. Renovate is a tool out there that does this by itself. We just tell him to search on the repo for, in this case, when I press the button to search on the repo based on the Renovate configuration for Django. It goes to the repo, searches for the Django dependency, and upgrades it to the latest. Usually, what it does, it upgrades the dependency to the latest minor and creates another pull request for the major version. So the teams can look and test both and to see if they can go to the major or not. But right now, we are completely relying on Renovate for this process.
Okay, thanks.
Thanks for the talk. I wanted to ask you what were the greatest challenges you faced in this project, because generating SBOMs is not trivial due to every difference that every project has. And how did you tackle this? Thank you.
So that's a big one because this is mainly the biggest challenge that we had, because working with multiple code bases is really challenging when you want to build an unified solution for SBOM generation, because you don't know other teams' code. You know the repos are out there, you know the languages they use, but you don't know the team's code. And we have proven that SBOM generation is much better after built environments. So if you create the CDXGen after you build your tool locally, the results that you'll have will be much better than the ones that just passing the repo to it. So clone the repo, run CDXGen, and generate the SBOM will not bring the same results. And having this working for multiple languages and multiple environments is really challenging. What we did, in our case, as we did this in the past for SonarQube, was to go and try to mimify the CI builds that we have of the team. So the way that the teams build their projects, we try to mimify that, creating multiple templates for multiple languages based on standards that we try to identify along the time. And based on that, we tried to create the templates the better that we could for this to work and to be scalable and to cover the much languages possible in our code base. But yeah, it's really challenging. Is it perfect? Of course not. Is it running for everything? No, it isn't. But we are here to making it better and try to identify patterns. Ideally, the best solution for this would be to try to put the team send you the response. If you think about implementing this in your own companies, try to make this process, but having the team delivering your response. Because they know their tools, they know how to build them, and they can provide you really valuable information in terms of bill of materials. I hope this answers the question. That's it. Thank you, everyone. I hope you enjoyed.